All right, chapter 3, section 3 is really just a continuation of 2. And we want to just add a couple vocab words, classify types of statement. We saw that most compound statements are true in some cases, and some are false in others. A tautology is a compound statement that is always true regardless of the true values and the simple statements that make it up. And we'll do an example of that. A self-contradiction is a compound statement that is always false. So when you do a truth table to figure out what a compound statement results in, if all of your true and falses are true, all your values, your truth values are true, it's a tautology. If all 4 of them are false, then it's a self-contradiction. Some statements are logically equivalent. Both compositions of the same simple statements have the same meaning, and their truth tables are identical. For example, if it snows, then I will go skiing, and I won't go skiing, or I will go skiing. And if I don't go skiing, then it won't snow. All are true, false, true, true. So these, let me see if I can get my pen out here. So these, that's a lot to do really fast. But if you process all of these, they'll come out to true, false, true, true in a truth table. And those are their final values. So if it snows, then I will go skiing. That's this one, right? A conditional. And that will end up with these values. You can also say it won't snow. That's a negation of the first statement. Or I will go skiing. And if you do a truth table for that, you will get the same truth values as well. So these two are logically equivalent, as well as this one. I won't go skiing, or if, well, it's a conditional. So if I don't go skiing, oh, it's up here, then it won't snow. Believe it or not, these are all logically equivalent because you get the same results in your truth table. A tautology would be all true, all 4 are true. A self-contradiction would be all 4 are false. Okay? And then we talked about De Morgan's law a little bit, distributing the negation and flipping the symbol. So in other words, right here, see the negation of P or Q, that results in this right here in their final values in the truth table. It's logically equivalent to distributing that negation to the P and the Q and flipping from an or to an and, because you will get the same 3 falses and a true as a result of your truth table. Okay, so you distributed that and flipped the symbol. A negation of that is another way to say this one, right? A negation of P or Q is the same as the negation of P and the negation of Q, and a negation of P or Q is a true, 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 false, or the opposite. Right. So this is a negation of that being P or Q, which comes out to the opposite truth values. That's a mouthful, isn't it? Okay, let me look at this one. We have a negation of P and Q. So P and Q turn out to be 1 true and then 3 false. But a negation of that is 1 false and 3 true. And that's logically equivalent to distributing this negation through the P and the Q and flipping the symbol to an or from an and you will still get the false, true, 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 which is a negation of the P and Q, or that. Okay, that's a mouthful. Let's practice that. This is all I have for 3, is just to practice these things and just also identify if you have a tautology, a self-contradiction, or neither. Most are neither, right? Because you don't have all 4 of the same thing. And then mention if any 2 statements are logically equivalent. So let's make some truth tables. Let me start here with this one. This is P and Q, and then conditionally, if then P. So let's just, we always, let me start over as far as I can. We always start with our P's and Q's. And then what are we going to need? We're not only going to be in need a P and a Q. I don't have any negations, but I do have something in a parenthesis. So I need that. And then I need the whole thing. P and, oops, I almost wrote the word and. P and Q. If P and Q, then P. Be careful with that. That's what it says. All right, so our traditional P's is T, T, F, F always. Our Q's always F, T, F, T, F, and then P and Q. So I made myself a little basic table, kind of reminding myself that this symbol is an and. It's called a conjunction, and all are F's but double T's. So all are F's but double T's. Okay. And then we're going to add a conditional. We're going to add a conditional right here. If then, all are T's except for the TF. So I'm going to do a little work here. This is first. Whatever's in this column is first. So I'm just going to take a moment. This is my little shorthand for this. Do not put this in Alex. I'm just showing you how I get what I get in here. So this is these right here, right? And then we need conditional P. So conditional P here was a T. P here was a T. F. Okay, and then according to my other sheet, any conditionals, they're all T's except for any TFs. So I happen to not have any TFs. So that means they're all true. So that's my final answer right there. And that is a tautology. Let me write it under here. I've got some room. Okay. All right, so let's look at this one. I need my P, my Q, try to make them skinnier. And then I'm going to need a P and Q. And then I'm going to need some, I'm going to need some negations. So I could have put my negations over here, but since I didn't notice, I'll just put them over here. I need a negation of P, I need a negation of Q. Now these are optional in your homework in Alex. You can add these columns. I find it easier to add more columns. You may not. It's up to you. It tells you it only grades the last column that you enter. So whatever you find the easiest. So I need to then do the negation of P and the negation of Q together. And then this last column will be what they asked. I'm trying to save a little room here. So typical P, typical Q, and then this is the same as this. So to save time, And negation of P, if that's true, this is false. That's true, false, so that's false, true, true. Negation of Q, so that's false, true, false, true. Okay, and then I need a P, negation of P, and a negation of Q. So F, F together with an AND. I go back to my AND. They're all false except for double trues. So I have a double true here. So the rest are false. And then therefore this last one is going to be this and that. So I'm going to take a minute and kind of right over here for a second. So what was this one? This was T, oops, sorry, F, F, F in this one. Got to make sure order matters. Okay, so I need this first. And then I'm going to end with this one. So this is going, so these are, make sure you get this in the right order. It's very, very important. All right, and then this whole thing was an and. So up here, again, ands, everything is false except for double T's. So I don't have any double T's. So my final answer is all F's. And that is a self-contradiction. Self-contradiction, right? That sort of makes sense. You've contradicted yourself. It's kind of like a double negative or something. Okay, so that logic doesn't work in any way, in any case. All right, this one over here is an or, a disjunction P, oops, Q, sorry, PQ. And the only other thing well, I'll put an easy one after the hard one. And then this will go here. So P, T, T, F, F, Q is always T, F, T, F, and then P or Q. Sorry, that looks like an A, but that's a Q. All right, my or column here, a disjunction, an or, all is T except for the FF, the double F. So all is a T except for the double F. Okay. Because that's an or. I go back to lesson 3.1 to understand why that is. I don't have time to put that on this. All right, so now I need to do a conditional. If this is true, then that. Okay, so a conditional. So I need that's a Q, by the way. So let me put it in order. So I need this first, T, 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 F, and then I need a P, no, a Q, a Q. So that's T, F, T, F. All right, and then a conditional says, where is it? Conditional, all T except for TF. TF is right here. All T, all double T's are always T's. Oops. And in this case, all T's except for TF. So that's my final answer. So that would fall under the neither category. Okay. Or neither. Okay. Last ones. P's, Q's, not P's, not Q's, and then that one, not Q, if then P. So let's see, T, T, F, F, T, F, T, F, not P, F, F, T, T, not Q, F, T, F, T. All right, so then I need not Q, which is here, and then, hold on, this is my little shorthand, otherwise I'll just mess it up. I can't do keep it all in my head. And then not P is second. So F, F, T, T. All right, that's, and then this is conditional again. So conditional, you'd think I'd remember by now, but I don't. Conditional if thens, alls are T's except TFs. So that's a false, true, true, true. That's my final answer. And that is, oh, look, this one and this one. So logically equivalent to number 3. Okay. TFTT. All right, last one. There's a couple biconditionals in here. So I need a P. I need a Q. T, T, F, F, T, F, T, F. And then that's a negation of that. So let me do this one first. If and only if Q. And then I'm going to need a not. Ooh, wait, that's different. But that's not a typo. I also need a Q biconditional P. Then I also need a not Q biconditional P. And then I need all of that together with an OR. Okay, so biconditional PQ, biconditional PQ. If there's 2 T's and 2 F's, if and only if. So if you have 2 T's, they're true, or 2 F's, they're true. If you have a T and an F in any order, they're false. So 2 T's are true, 2 F's are true, and these are false. All right, Q and then P. So Q and then P is still going to be a TT. Yeah, these are still going to be the same because you still have one of each and that one. Probably could have known that, but all right, now I need the opposite of this one. And I need an OR between this one and that one. So TF, FT, FT, TF. And the ORs say, the OR says it's a disjunction, so all T's except for any double F's. There aren't any double F's, so they're all T's. So that is a tautology. Not tan. Tautology. Okay.